I'm going to show you how to use the calculator to solve simultaneous linear equations. So I've got two simultaneous linear equations here, y equals 2x take 3 and y equals 10 minus 6x. On the graphics calculator, go into the menu and choose graph, which is number 5. And you can see here, if it's on the default setting, that you should have y1 and y2 and y3. If it's not, you can go to type and you can just make sure that it's set to y equals. Okay, we've got that. So now I'm going to put the first one in to x. Make sure you're using the x that is here. Don't pick the x up there, and I don't know why they make it so tricky. Use this one. 2x take 3, that's done. And the second one is 10 take 6x, and that's done. So now to draw that graph, I just click over here on F6 for draw, and you can see that it's displaying it here with an intersection just there above. Looks like it's a little bit above the x-axis. So to find out where that is and what the coordinates are, I click on Gsolve, F5, and again when it comes up here, you can see this is intersect. Click on that and it tells me that x is equal to 1.625 and y is equal to 0.25. And that's your solution to that one. Let's do another one. Okay, I've got two more that I've typed in here. 3x plus 5y equals 4 and y equals 0 or negative 0.6x plus 2. Now the difference here is that this first one is not in the form y equals mx plus b like the second one is. It's in the form x plus y equals the constant over here. So I need to rearrange that formula before I can put it in to here. So first I'll just delete these. Delete, yes. Delete, yes. Okay, I can put in the second one already because that's all ready to go. Negative 0.6x plus 2. That's okay. Now for this one, rearranging this, let's see what I have to do. If I just start a new line here. So if 3x plus 5y equals 4, I want to get it in this form, so I need to have the y's on the left and the x's on the right. So let's take away 3x on the right hand side. Okay, so far so good. But I've got 5y there, which I can't change the y value on this graphing function, so I need to probably divide everything on the right hand side by 5 to get rid of that 5y. Okay, I've done that. Now let's see how that goes when I put this into the calculator here. So if I try putting this in, y is equal to, can I put a fraction in? I can. So let's put in brackets, 4 take 3x, close the bracket, hit the fraction key, put a 5 in. Okay, so that's 4 take 3x over 5. Let's see what happens when I hit execute and draw. Aha! Now, this is interesting, isn't it? Because I can see that my two lines have popped up as parallel lines. So there is nowhere where they cross over. Bit of a trick question, that one. And you can see, if I went through the division over here, negative 3 divided by 5 is actually negative 0.6. So they've got the same slope. And having the same slope means that there is no solution for this one. But anyway, I've shown you how to rearrange an equation and put it into the calculator so that you can find your answer. Now sometimes when you do this on your calculator, for reasons I don't really fully understand, the spot where the lines intersect will be off the screen somewhere. And I'll just show you, like you can't even see where the lines are. Maybe they're off here somewhere. So it might require you moving the screen around to see where it is, or it might require you maybe to zoom out to find out where they cross over. We're not going to find it here because they're parallel, but maybe that will help you find it. Or sometimes you have to go to viewing window here And you need to change the minimum for the x and the maximum for the x just to give it a more sensible range, because sometimes the range here could be like in the thousands or something like that, which means that you're missing out on seeing where the lines cross over. And if the lines aren't crossing over on the screen, if you can't see where they're crossing over, the solver won't find it. So sometimes it just takes a bit of messing around to get it, but you should be able to find it eventually. Anyway, I hope that's been helpful.